dear friends, welcome to the lecture of ordinary differential equations. We are studying exact differential equations of first order, and in this lecture we shall study rules 3 and 4 to find integrating factors. In the earlier lecture we have studied rule 1 and 2. The equation we want to make exact is of this type: m dx plus n dy is equal to 0. And if this is not exact, it can be made exact by multiplying the equation by integrating factors. And the third rule is when this partial derivative of m with respect to y minus partial derivative of n with respect to x divided by n is a function of x alone. See, what is the condition for exactness? Partial derivative of m with respect to y must be equal to partial derivative of n with respect to x. Then the equation becomes exact. So if it is not exact, then this difference is not 0. And if this difference divided by m is a function of x alone, only of x, there is no y term in this expression, then suppose suppose as f of x. Then integrating factor is e to the power integral fx dx. So this is the third rule. Now what is the fourth rule? See, instead of this difference, the difference is taken as partial derivative of n with respect to x minus partial derivative of m with respect to y. Actually these expressions differ by sign only. This is negative of this one, but that is divided by m, and that becomes function of y alone, say f of y. Then integrating factor is equal to e to the power integral f of y dy. So that means we have to check which is entire function of x, this expression, or if not, then try for this expression, dou n by dou x minus dou m by dou y divided by m. And if that is function of y alone, then the integrating factor is this one. So these are the rules 3 and 4. And now we shall solve problems on it. I have written problems here. Some problem we will solve first. These two problems we shall solve, and then these are written for practice. You should solve these two. Now we shall consider the solution of problem first. So this is the equation which is we are considering for exact form, to convert into exact form. So we shall write solution for first. We compare this equation with m dx plus n dy, comparing the given equation with m dx plus n dy is equal to 0. We get, what is m? You see, it is x square plus y square. Coefficient of dx is m, and coefficient of dy with negative sign we have to consider minus 2xy. Now which rule we should try? Here we have written only two rules, 3 and 4. There are actually 5 standard rules. The rules 1 and 2 we have seen in our earlier lecture, and before that also we have seen what is the integrating factor by inspection that we have to find out. So all these are to be used. Which rule is to be used, that is we have to decide by observation. Now it is clear that if I have written the problems here, means these are dependent on rule 3 and 4. But randomly we should decide which rule is to be used, first, second, third or fourth. So that will be on observation and also by trial. So here we shall see what is, but you can see here the partial derivative of m is fixed to be with respect to y. And that is, first is to be differentiated partially with respect to y, and second is to be differentiated partially with respect to x. In both the rules the derivatives are the same. So only there is difference of sign of this expression at numerators, and therefore we shall write partial derivative of m with respect to y, and that is 2y. It is easy. X is to be treated as constant, its derivative is 0 and derivative of y square is 2y. And what is the partial derivative of n with respect to x? That is with respect to x. Y is to be treated as constant, so minus 2y is constant, derivative of x is 1. So it is minus 2y. And thus dou m by dou y is 2y, dou n by dou x is minus 2y. Now what will be their difference? If you see. Therefore, dou m by dou y minus dou n by dou x is 2y minus of 2y, that is 4y. And you see, if this is the difference obtained, that is divided by n. If we divide by n, what is n? It is negative 2xy. So 4y divided by minus 2xy. So this y cancels, and one term, 4 by 2. 4 by 2 is 2. So that will be minus 2 upon x. You see, quotient of these two. So this divided by this quantity, minus 2 upon x. And therefore it is a function of x alone. Now if we divide by m, what happens? If this is divided by m, then it is not entirely a function of x or a function of y. And thus the first rule is useful here. And therefore dou m by dou y minus partial derivative of n with respect to x divided by m, not m but n. We have to consider this n. This is 4y divided by minus 2 times xy, and actually this is y is cancelled, 2 remains at negative sign is separate, 2 remains at numerator, x remains at denominator, minus 2 upon x. And you see, this is a function of x alone. Suppose that is f of x, function of x alone, and thus the integrating factor is given by e to the power integral fx dx, and therefore by rule 3 if is e to the power integral fx dx, that is equal to if is e to the power integral minus 2 by x dx. And it is easy to write the integration. Minus 2 is constant with respect to the integration, e to the power minus 2. Integration of 1 by x dx is log x. And again, this can be simplified by using law of logarithm. This minus 2 we can write as the index of x or power of x, and this is e to the power log x to the power minus 2. Exponential and logarithm are inverses of each other, and therefore this remains x to the power minus 2, or which is equal to x to the power minus 2, or which can be written as 1 over x square. So thus if is integrating factor is 1 upon x square. And now once the integrating factor is obtained, we should have to multiply the original equation, that is given equation, which is this one, by the integrating factor. And now I shall suppose this equation as 1, which is the given equation. So multiplying the given equation by 1 upon x square. Therefore our given equation here, it is 1. We are suppose 1. This is the given equation. For solution for 1 we are writing, and this is the original equation. So this equation is to be multiplied by integrating factor by 1 upon x square. We get. Now the resulting equation I shall write here. See what will be the resulting equation. 1 upon x square, we have to multiply, means divide each term by x square. I am writing directly from this equation. Divide this by x square, we shall get 1. I am writing here 1 plus y square upon x square into dx minus 2xy divided by x square. One term of x from numerator and denominator cancels, and it remains minus 2y divided by x. You should check it. It is divided by x square. So minus 2y remains at numerator and x remains at denominator into dy is equal to 0. This is exact. We can check. But that's why the integrating factor is obtained, and if the given equation is multiplied by the correct integrating factor, the equation results into or reduces into exact form. And this is exact because if you find the partial derivative of this with respect to y, that is this is 0 and it is 2y divided by x square. And what is the partial derivative of this with respect to m? That is 1 upon x. The derivative of 1 upon x is minus 1 upon x square. That minus into this minus becomes plus 2y upon x square. You can check it, which is exact. And its solution is, so its solution is given by the rule that we have used for exact equation. So its solution is integral coefficient of dx. That now the equation is reduced into exact form, and now this is our m and this is our n. So but we have used m and n for the original equation, so we are not writing m n here. We will write the solution directly. M dx, or the coefficient of dx, this is to be written 1 plus y square upon x square into dx. Here y is to be treated as constant, and plus integral terms of n, terms of this coefficient of dy, which does not contain x, means free from x. And we observe that there is only one term in n, that is minus 2y upon x, and it contains x. So if there is no term, then it is 0. 0 into dy. So this is the rule of solution of exact differential equation. And if this is only of this type, then we have written minus 2y into dy. But it contains x, so we have to leave that term. And now evaluate the integral first only. The integral second is 0. And cos c is the constant of integration. Now what is integration of this with respect to x? 1 dx. Integration of 1 dx is x. And so I shall write here integration is x for the first, plus. Now you see for the second, y square is constant. So I shall write y square as it is. And what is integration of 1 upon x square? Integration of 1 upon x square is into dx is integration x to the power minus 2 into dx. And by power function, it will be x to the power minus 2 plus 1. That is minus 1 divided by minus 1. So it is the integration. Or that is x to the power minus 1 divided by minus 1. The integration of 1 over x square we have written here. And this is 0, and therefore is equal to c. And this can be simplified as, we write negative sign here, and this is 1 upon x. X to the power minus 1 means 1 upon x. To eliminate the fraction, we should multiply it by x. Multiplying this by x. So what we shall get? X into x, that is x square. And this negative sign I shall write first, minus. And x into x to the power minus 1, which is 1 by x, that is 1 product. And therefore this is minus y square is equal to cx. So this is the general solution. And thus we have completed the solution for the first problem. Now we shall solve the second problem. You see, the second problem is 3x square into y to the power 4 plus 2xy into dx and plus 2x cube y cube minus x square into dy is equal to 0. Again, first we shall compare this with m dx plus n dy. Now I shall suppose this equation as 1. So it will be better to write the equation and then comparing the equation with this that we can write. But I am referring here itself as 1. So that is the given differential equation. Now what is m? M is the coefficient of dx and n is the coefficient of dy. If there is a separate here minus sign, that sign is also to be considered, as in earlier example we have taken minus 2xy as n. So write m and n, and then what we have to find out is, so we get m is 3x square y to the power 4 plus 2xy, and n is 2x cube y cube minus x square. These are m and n. Find out the partial derivatives of m. We have to differentiate with respect either for third or fourth rule, the numerator differ by minus 1, or these partial derivatives are to be obtained, m with respect to y and n with respect to x. So therefore we shall first find out what is partial derivative of m with respect to y. It is easy. When we differentiate with respect to y partially, x is constant, so 3x square is constant, and derivative of y power 4 is 4y cube. 4 into 3 is 12. 12x square y cube plus derivative of this, partial derivative of this with respect to y is 2x is constant, derivative of y is 1. And what is partial derivative of n with respect to x? That is with respect to x means y cube is constant, and derivative with respect to x cube is 3x square. 3 into 2 is 6 x square y cube minus 2x. So this is the derivative of m, partial derivative of n with respect to x. Now if we subtract this, so dou m by dou y minus dou n by dou x, what is the subtraction? You see the subtraction will be 12x square y cube minus 6x square y cube, that is 6x square y cube, and 2x minus of minus 2x, that is plus 4x, and this is to be divided either by n or by m, and we should get either function of x alone or function of y alone. So in that way we have to decide which rule is to be used. Now if I divide this by say n, so whether we shall get a term of x alone. If we divide by n, we must get a term function of x alone. So that is, I shall write here 2x cube y cube minus x. Now see, this cannot be simplified. We can see this cannot y cube this way cannot be cancelled, because there is here addition and here subtraction. So this will not work. And if I consider that instead of m, the denominator as m. So what is m? 3x square y power 4 plus 2xy. Now from this, if we take y common from the denominator, then that will be, or you can see which can be taken common. From numerator we can take 2x common. So 2x common, and what remains in bracket is 3x y cube plus 2 will remain at the numerator, and at the denominator what remains which can be taken common is x into y, and in bracket it remains 3x y cube plus 2. See, this term cancels, and this x also cancels. What is remaining is 2 by y, which is function of y, and therefore this will fourth rule can be used here. So third cannot be used, but fourth can. So this is to be done by observation and by trial and error method. So try for different rules and then get the correct integrating factor. But one thing is to be remembered, as See, we have subtracted this dou n by dou x from dou m by dou x, but in the rule dou n by dou x minus dou m by dou y is there. Means we have to subtract this term from this one. So we should use by rule 4. Or earlier I shall write, therefore dou n by dou x minus dou m by dou y is equal to. See, here there is only negative sign, and thus this expression will be minus 6x square y cube minus 4x. Subtraction is reversed, and now it is divided by m. Therefore dou n by dou x minus dou m by dou y divided by m is equal to. Now we can take negative sign common. This minus 2x can be taken common from this, and what remains in bracket is 3x y cube plus 2, and from m also I shall take xy common, and in bracket it remains, if I take xy common from this, x 3x y cube plus 2, or this term cancels, this bracket cancels, and one term of x cancels here, and therefore this is what remains is minus 2 upon y. This is function of y. Say function of y alone, that is f of y we denote, and therefore by rule 4 the integrating factor is this one. By rule 4 if is the integrating factor is this one, e to the power integral capital F of y dy, or that is e to the power integral minus 2 upon y dy, and that can be evaluated as earlier. So that is the integrating factor is e to the power, minus 2 is constant, and as earlier the integration here is in y, so 1 upon y dy is log y, and that is equal to, so if is e to the power minus 2 integral 1 by y dy, or that is e to the power minus 2 log y, or that can be written as e to the power log y square, not y square but y to the power minus 2, using law of logarithm. E and log cancels, this is y to the power minus 2 or 1 over y square. Thus we have obtained the integrating factor, and that is the major part in the solution, to obtain the exact integrating factor. Now the rest part is usual, that means we have to multiply the given equation by this integrating factor. So multiply the given equation we have numbered as 1 here. So multiplying the given equation by 1 upon y square, we get. Now see, this can be done directly. 1 upon, we have to multiply by 1 upon y square means divide each term by y square. If you divide this term by y square, what we shall get is 3x square y square, plus this is to be divided by y square, we shall get this as 2x upon y into dx, plus again this is to be divided by y square, we shall get 2x cube y upon y, and minus x square upon y square into dy. Verify this is equal to 0, which is exact. This equation is exact, and now its solution can be written. Its solution is integration, this coefficient of dx, m now is changed or transformed into this form. So the integration of this with respect to dx. And here one thing is to be treated as y is to be treated as constant 3x square y square plus 2x upon y into dx. Y is constant. And plus integral terms of n means coefficient of dy which does not contain x. Now you see this term contains x, this also contains x, so that means there is no term of n which does not contain x, and if this happens we write 0 into dy is equal to c. Or if one term is there which does not contain x, then that means the term must be either constant or term of y, then that term separated can be written here. So we have to integrate. What is the integration of the first? Y is constant, so 3y square is constant, and integration of x square is, we shall write directly, integration of x square we know is x cube by 3 plus 1 upon y is constant, integration of 2x, 2 is also constant, so 2 by y is constant, integration of x is x square by 2 and is equal to, right side I shall write as c. Here 3 by 3 is 1, 2 by 2 is 1, and one more thing we can do is we can avoid this fraction by multiplying this by y. So multiplying by y, what we shall get? Multiplying by y, we get this is y cube x cube, or that can be written as x cube into y cube. And next term is plus x square. We are multiplying by y, means this 1 upon y cancels, 2 cancels with this 2, and it is plus x square is equal to cy. C is multiplied by y. This is the general solution. So thus we have solved the first and second problem. Now I shall leave these problems for you to solve these yourself. And one thing I want to tell you is that we are referring the book Introduction of Differential Equation, Introductory Course in Differential Equation by D.A. Murray, and Ordinary and Partial Differential Equation by M.D. Raisinghania. So I shall give the name of the book's details in the description of this video, also the playlist. The remaining part we will continue in our next lecture. Thank you.